Today we're going to take this one step further and go from the systems to the matrices. And so we have a few definitions and probably a few new methods of solving matrices than we learned in Algebra 2. So first, let's take a few minutes and go through the definitions. A matrix, first of all, is a rectangular arrangement of numbers in rows and columns enclosed by brackets. The dimensions of a matrix are the number of rows by the number of columns. In mathematics, this capital X means by, not times, like a 2 by 4. That would be rows by columns. And an element would be one piece of data within the matrix, each entry. An element can also be denoted by its position. So an element in row 2, column 3 will be denoted as A23. So if we take this matrix, you see it's A. That's where the A comes from. What element is in row 2, column 3? Row 2, column 3. That gives me a 5. So 5 is in row 2, column 3. How about if I asked for A1, 2? So that would be row 1, column 2 would be 2. So since there are 2 rows and 3 columns, it is a 2 by 3 matrix. That would be its dimensions. We also have some special matrices. The first is a square matrix. A square matrix is a matrix with an equal number of rows and columns. And here I have an example of a 2 by 2. The rows and the columns are identical in how many elements. Then we have a coefficient matrix, and it is a matrix whose entries are the coefficients of an equation in a system. So here is my system of equations. 2x plus 3y minus z equals 10. 3x minus y plus z equals 1. X plus 2y plus 4z equals 5. So if I am writing a coefficient matrix, I just take the coefficients used. So this would be 2, 3, negative 1. 3, negative 1, 1. 1, 2, and 4. And I have my coefficient matrix. Next, we have the augmented matrix. And an augmented matrix is a coefficient matrix including the constants. So same system. Notice this part is all the same. Then we've added in these constants of 10, 1, 5. So we draw a line and we put 10, 1, 5. That's what makes it augmented, because we not only have the coefficients, but we have the constants or solutions. Another new type of matrix for you might be called the row echelon form. For a matrix to be in row echelon form, the main diagonal is either 1s or 0s. Our main diagonal always starts at the upper left-hand corner and diagonals. Notice it is a 1, 1, 1. In this one, this is also row echelon. We have 1, 0, 0. So that main diagonal is full of 1s or 0s. Also, the first non-zero element of each row is 1. So here's a non-zero. That's 1. Next row, the first non-zero is 1. Next row, the first non-zero is 1. Let's check this one out. The first non-zero is 1. Next row, the first non-zero number is 1. Last row, there is no non-zero, so we're good. Also, the rows must contain only zeros in the last row. So if you're going to have a row of zeros, it must be in the last row. And that occurs here. All these are zeros. Notice it's not the first row or the second row, but it is the third row. This matrix doesn't have a row of zeros, so we're okay. It's still row echelon. And the last qualification is all the elements of under the main diagonal are 0. What haven't I used? All the main elements under the diagonal are 0. Notice these are all 0. These are all 0. Then I have row echelon. I always want it to begin with a 1. Okay? So this says solve each system. Let's see. I think here we have our augmented bar missing. So if we take our matrix and we go back to our equations, notice this would be x's, y's, and z's. So here, z equals 3. In this second row, 1y plus 1z equals 2. And in this first row, 1x plus 2y plus 0z equals 4. So now we can just substitute in. So since z is 3, I'm going to put that there. Y plus 3 equals 2. Subtract 3. Y equals negative 1. So I have negative 1 for y, 3 for z, and then we'll substitute those in here. X plus 2 times y, which is negative 1, equals 4. X minus 2 equals 4. Add 2. X equals 6. We always put our point in alphabetical order. X 6, y negative 1, z 3. 6, negative 1, 3. Let's try another one. This time my matrix is 1, 2, 0, 4, 1, 0, 1, negative 1, 2, and 0, 0, 0, 0. Since this bottom row is all zeros, we end up having the equation 0 equals 0. If you have 0 equals 0, what does that mean? That it is a true statement, and there are infinitely many solutions. Okay? In this equation, we have y minus z equals 2. And here we have x plus 2y equals 4. So if we have 0 equals 0, we know there are infinitely many solutions. So I am going to write this in terms of z because that was my last row. So I would have my z. So when I'm looking for the y spot, right here I have y minus z equals 2. If I want what y is in terms of z, I must solve it so it reads y equals. So I would add z to both sides, and I get y equals 2 plus z. So then in the y spot, I put 2 plus z. Then I use this first equation, x plus 2y equals 4. And I will substitute in 2 plus z in my y spot. So I have x plus 2 times 2 plus z equals 4, which is x plus 4 plus 2z equals 4, which if I subtract 4 from both sides, I get x plus 2z equals 0. And since I'm looking for the x spot, I have to have it read x equals. So I subtract 2z from both sides, I get x equals 2z. Excuse me, negative 2z. So my point is negative 2z 2 plus z, and z. And I know this is infinitely many because it was a true sentence, and it means I can pick any value for z, add 2 to it, and I'll have my y value, double the z value with a negative, and I'll have my x value. All right. Now we're going to go to the Gaussian elimination. And when we use Gaussian elimination, we want to get our matrix in row echelon form. So it means we want our first term of our matrix, first element, to be a 1. So we can do these operations to it in order to get the first one to be a 1. So I would like to have a matrix that reads 1 something something and then a value. 0 1 something something. 0 0 1 something. Then I am in my row echelon form. As long as I get the x value coefficient to be 1, a y coefficient to be 1, and a z coefficient to be 1. I want to move to row echelon. So I can do that with any two rows. I can change them around. I can multiply a row by another row. Then I can add and subtract that multiple times another until I can get it manipulated down to this row echelon form. Now, I've done it one way behind these boxes. There are several ways you can do Gaussian just so that we get the x coefficient to be 1, the second row, the y coefficient to be 1 and x to be 0, and the third row, a 0 for x, a 0 for y, and a 1 for z coefficients. So the method I've chosen for this system of 3x plus y plus 3z equals 14, x plus y plus z equals 6, negative 2x minus 2y plus 3c equals 7 is this. I did not choose to do this, but we could have just switched these two around and I would have a 1 right there. First time I did it, I didn't see that. So instead, the first time, I wrote down my coefficients. 3, 1, 3, 14, 1, 1, 1, 6, negative 2, negative 2, 3, negative 7. And I saw that if I add row 1 and row 3, I will get a 1 in this first position. So I'm just going to do the adding underneath here. That would give me a 1. 1 minus 2 is negative 1. 3 plus 3 is 6. 14 minus 7 is 7. So I can now make that my first row. 1, negative 1, 6, 7. Notice the second row stayed the same. 1, 1, 1, 6. And the third row stayed the same. Negative 2, 3, negative 7. Because I'm manipulating one at a time. I also noticed then I want this to be a 0. And I want this to be a 1. I have a 1 there, but I need this to be a 0. So I noticed if I double row 2 and add it to row 3, I will have a 0 here because 2 plus negative 2 will be 0. So I'm just going to do that underneath. Double all these. 2, 2, 2, 12. And when I add them together, I would get 0, 0, 5, 5. Well, it's looking like I have 0, 0, and if I divide these both by 5, I'd have my 1. So I'd be in this row. So by me manipulating that, it came out to be 0, 0, 1, 1 when I take and multiply this by a fifth. So notice, row 1 is still the same. By me getting here and dividing it all by 5, I got row 3 to be 0, 0, 1, 1. Notice my row 2 remained the same. Negative 2, negative 2, 3, negative 7. So how I got rid of that is I took row 2 times negative 1 and added it to row 1. And I get row 2 times -1 would be a -1, a -1, a -1, and a -6. So that gives me 0, 0, 0, 0. Oh, wait. Add it to row 1 gives me 0, 0, 5, 1. So 0, excuse me, this is 0. -1 makes -2. 6 minus 1 is 5. And 7 minus 6 is 1. So I see here, I need this to be a 1. So to have it be a 1, all I have to do is divide all these by a -2. And I have 0, 1, -5 halves, -1 half. So now if I take my equivalency, this is z, so z equals 1. Then this would be y minus 5 halves z, which is 1, equals -1 half. That's y minus 5 halves equals -1 half. Add 5 halves, and I get y equals 4 halves, which is 2. And then I can plug those into here, which reads x minus y, which was -2 then, plus 6 times z, which is 1, equals 7. X minus 2 plus 6 equals 7. That's x plus 4 equals 7. So x equals 3. So my solution is 3, 2, 1. That's how you do Gaussian by hand. And you will have to do some by hand. And there are different ways to go about it. But as long as you get to where you have a 1, a 0, 1, a 0, 0, 1, you should be okay. How we can do Gaussian on the calculator is first enter your matrix in matrix A, which would be edit. Then you will choose matrix, math, and go all the way down to B, which is row reference, and then do matrix A, enter. And then you should get your solution just like here. You should get this matrix to show up. And we'll do one on a story problem on the next page. Okay? So here we go. We got food shelters having monthly food costs. And they serve so many people and they give so much to charity. Okay? Here it says our model, the food will equal A times the number of servings plus B times the number of receipts for charity plus C. So the coefficients of A are right here per equation. The coefficients of B are right here per equation. Coefficients of C, it's 1C. So I have 1, 1, 1. Okay. So it says F equals. So this is my F. So this is where my equal goes. All right. Now we'll put that in the calculator. So let me get my calculator up. All right. So we would go to our matrix, which is second x negative 1, and we want to edit. And we'll edit matrix A. And this is going to be a 3 by 4. We're going to put this in first for n's, this in for r's, and this in for my remainders of c's. And this will be my augmented part of f. So actually, maybe we should write it this way. Equals 1300, equals 5300, equals 6500. Okay? So it is a 3, enter, by 4, enter, and then we have 1800, 5000, 1, 3200, 12,000. Whoop, I think I missed one. I missed my 1300. Well, 1,100. Okay, and then I have 3,200 in my second row. 12,000. 12, 1, 2, 3. 1 and 5,300. And then I have 4,500. 13,000. 1 and 6,500. Okay. And then I want to quit. So I'm in my calculator screen. Now I want to go to matrix and math. And I want to go down to row reference. So I just scroll down. I think they said it was B. R ref. Enter. And I put my information in matrix A. So I go back to matrix. A is highlighted, so I hit enter. And then I hit enter. And I get these decimals. So if we want to see it in fractions, push your math button. Fraction. Enter. And I get x equals 248. Oh, I must have a mistake there. Let's check my matrix, because I don't think we should get that. Matrix A. Let's see what, edit it. Oh, right here, 18,000 should be 1,800. I always get too many zeros. And 5,000. 1,800. 5,000. The rest okay? All right. Let's check my 1,300, 5,300, 6,500. All right. Now let's quit, and we can do that again. So I'm just going to go second, enter, row reference of matrix A. And now I'll do math. There we go. That's what it should be. So I get F equals 4/7 n plus 16/35 r minus 14,100 divided by 7. Okay. So then with that, we should be able to predict for 3,500 people, that's N. Charitable receipts, that's R, of 12,500. So we would say F equals 4/7 times 3,500 plus 16/35 times 12,500 minus 14,100 divided by 7. And put that in your calculator. What do we get for an approximation of F? $214.29 is what it should cost me to serve 3,500 people. Okay, with that, you should be able to work on your assignment. If you need to rewind here and pause or whatever you need to do, go ahead and do that.